And we also discussed deeply about this, yeah, because in the APIX are very interested in the IXP databases. Okay, and also peering DB update by Arnold, and manners by Andre of ISOC. Manners are, you know, that in a kind of how to secure the platform of the IXPs, that kind of things. Yeah. So these presentations are very interesting. And also Chifu of the API, IPNIC, he made a presentation about an APNIC activity, about an developing an IXPs in Asia-Pacific regions. And also, we had a good presentation from the world. Hurricane has a lot of internet exchange connection. So they share, they request or recommend us to use in JSON, that kind of things. Yep. So, and also we had a panel discussion about developing a new IXPs in each country. So Brian conducted the panel, and Thailand, the Nepal, and Korea, and China, Malaysia, and Singapore. These, the key person are on the stage and discussed how they developed their new internet exchange in their countries. And also we had an administrative sessions, and we are collecting the membership fee this time. And also we had an election of the steering committee. And also we reported on peering Asia. Okay? And also we had an updates from the IXPs, from these IXPs. Okay? And after the selection, we had a new steering committee member, and I am the chairperson, and BJ of the Equinix becomes the treasurer, and other three are still the terms of office. So AJ and Zo and Haryanto, these are the new steering committee members. So we run the APIX this year with these members. So this is an update about an APIX. And next I'd like to just a little about talk about the peering Asia. So you know that the peering Asia is a new open and neutral peering event in Asia-Pacific regions. So just like, you know well, that the Global Peering Forum, GPF, European Peering Forum, EPF, this type of peering event. Yeah. And the relationship between the APIX and peering Asia is just like this. So APIX Association, in the APIX Association, we established a working group for peering Asia, and we recruit each time the host to organize the peering Asia X.0. Yep. So first one, it was organized by the Japanese internet exchanges. So this was in the peering Asia 1.0. And the hosts are described here, BBIX and Equinix Japan and JPIX and JPNAP. And we had this event in Kyoto. Yeah. So the season was very good, and you could see the autumn leaves there. And also this is a very famous temple, the Golden Temple. So a lot of attendees enjoyed Kyoto. Okay. And thank you very much for sponsors. Luckily, fortunately, we had 23 sponsors. So these are the list of the sponsors. We cannot use their logos after the event, so only the name. Yeah, so thank you very much. And as you know, the event architecture, we had a 2 days event. So mix of the peering meeting and conference and peering personals, and of course the lunch, social party, and the coffee breaks. And at first, we are assuming the 200 attendees. And these are the feature of the conferences. Yeah. So approximately a lot of people are there. Okay. And also, we had peering personals. So a lot of the ISPs made a presentation in 1 minute. And also IXPs had made a presentation. And the private meetings like this, and we had a lot of tables, and some sponsors got a private meeting room. So they have a lot of meetings these 2 days. And this is a social, yeah. And finally, we got attendees, 239 attendees from 114 ASNs. These are not only in Asian Pacific, including Japan, but from North America and Europe. So this is a profile of the attending ASNs. For regions, the Japan is the most the attendees attended ASNs, 48. And from APAC, 40 ASN attended. And North America, 18, and from Europe, 8. And country by country, so in APAC, and Malaysia, Singapore, Hong Kong, Korea, China, Australia, Vietnam, Thailand, Taiwan, Philippines. So a very lot of APAC ASN networks joined this meeting. And also from the US and the UK, Netherlands, and Germany. Yeah, those people are attended, and they had a lot of meetings there. Yeah. And this is a result of the survey, the almost good reputation. So the Appearing Asia 1 was meet their expectation. And also, if we have the future Appearing Asia event, then they will attend that next one. So thank you very much. Appearing Asia 1.0 was a great success. Yeah, and almost attendees wish the next one. So according to the survey, the Hong Kong is the most promising place. Then we will have the Appearing Asia 2.0 in Hong Kong, October 24th to 25th this year. So Kenneth and comes, please come. So from now, the announcement of the Appearing Asia 2.0.
So, hello everyone. Just to introduce myself, in case you don't know me, I'm Camps. I'm one of the program committee from HKNOC.
Hello, good afternoon, everyone. I'm Kenneth Chan from Hong Kong INEX.
Yeah. So, as Toyama-san mentioned, that we are going to be the co-host for Appearing Asia 2.0, together between HKNOC and Hong Kong INEX. Yeah, so a little bit information about Hong Kong. So Hong Kong is like a center of Asia geographically. So from most of the places from Hong Kong, you can reach like 5 hours. Like from Hong Kong to Kathmandu is also 5 hours. And Hong Kong has a visa-free entry for most of the countries. And there's a lot of choice of accommodation, activities, entertainments. A very busy hub for in Asia.
Yes, and here is some information about the host. And Hong Kong INEX was founded in 1995, and it is the neutral and the independent INEX in Hong Kong. We are carrier neutral, we are ISP neutral, and we have 217 participants now. And about HKNOC, HKNOC is a group of volunteers. They joined force for the Epicot APAN 2011, and they dedicate to serve the development of the internet in Hong Kong.
Yeah. So here's a detail for Appearing Asia 2.0. We already secure the date and the location of the event. So it's going to be 24th and 25th. Of October this year. It's Wednesday and Thursday, so you can take your time to transit, and hopefully you could stay behind or stay ahead and enjoy Hong Kong. The venue is going to be in Kowloon Vigo Hotel, which is in Tsim Sha Tsui. This is a very busy area, so you can, if you So there's a lot of, also a lot of alternative other hotels in that area, in Kowloon area. So there's a lot of hotel choice that you can have. The conference capacity that we can host is, we can host 200 plus in the conference hall in that hotel. And there's a lot of breakout rooms, so in case you want to be having your private room, then be a sponsor of, and it's very walking distance to the train station, a lot of cultural activities, a museum, etc. And of course, Hong Kong is famous for food. So please come to Hong Kong to have dim sum.
Yeah. And so please save the date, and we hope to see you in Hong Kong. And also please sponsor us for the Peering Asia 2.0 in Hong Kong. Thanks again.
Yeah. Is it the last time?
Yeah. Okay.
Yeah, so see you in Hong Kong. If you have any questions, please feel free to reach out to Kenneth and me. And virtually, we also have a lot of other HKNOC program committee members attending RPCOT. So you can also reach out to them, and hope to see you again. So we'll see you in Hong Kong. Yeah.
Any questions for the Peering Asia team or for Toyama-san? It's always Tom.
Yeah, sorry. Just a more of a statement quickly for Toyama-san. For the AS locations, you should mark international. There are many networks that don't exist in a single location, and that'll probably change the statistics quite a bit.
Like a global or international, right? Yeah. Okay.
Thank you. Thank you for your
Thank you, Paul.
Thanks, guys.
Okay, thank you.
Next up, we've got Martin Sermad from NIX CZ talking about the Phoenix security project. Please welcome Martin.
Thank you. So good afternoon, everybody. I'm Martin Semrad. I'm from NIX CZ, from Czech Internet Exchange Point, and I will give you some more information about exchanges which we operate in the Czech Republic and in Slovakia later. But now I would like to give you a presentation about the Phoenix project, which is membership initiative on our platform. And at first, I would like to ask you, how many of you never heard about Phoenix project? So it's a lot. So, okay. So I will try to describe you in next few minutes what the Phoenix project is about. So try to move with me in time 5 years back to the Czech Republic and to March, when during 4 days the most important telco operators, medias, banks, and the most important search engine were during 4 days under huge DDoS attacks. As I said, it was for the most of the networks in the Czech Republic, it was the problem, because they didn't have any processes inside networks how to fight against DDoS attacks. They were not able to find source of these DDoS attacks, because source of these attacks were outside of the Czech Republic, outside of our country, and these DDoS attacks were flowing through transit providers and through our infrastructure as well. But the problem was that the sources or upstream operators were not communicating with our members. So for them it was very hard, because they had overloaded their links or their upstream links and links to NIX CZ as well. And after these 4 days, they asked us if we can do something on the platform of Neutral Exchange Point. And after the discussions in our association, we started a Phoenix project, which you can imagine like a club of trustworthy companies, and they use the separate VLAN in our exchange point, which we call as the secure VLAN, which is the technical tool. And the main goal of this was that during the DDoS attacks, Czech eyeballs need to connect to our local content in the Czech Republic, like banks, home banking, media, their emails, and to connect to our local search engine. And we wanted to be also faster than government regulation because, as I said, the aim of these DDoS attacks were global for all economy, and it was publicly communicated in media. So we decided that if we want to do something, we need to set up a very high criteria for members who will be certified that they are members of this project. And as some kind of last resort technical opportunity, we are able to provide some island mode for attacked networks in the Czech Republic. So after this discussion in January 2014, 6 companies in the Czech Republic decided to start this project. And you can see that there are hosting companies, our National Research and Academic Network, top-level domain registry, and, for example, O2 Czech Republic, which is the incumbent telco operator in our country. And NIX, as a neutral organization, is acting like a supervisor over the rules of this project. But how to imagine what are these rules? We decided to prepare two levels of rules. One are organizational rules, which means that every member have to apply this criteria or these rules to their processes inside their networks. So it means that they have to move, for example, in contracts, these rules to the end users. For example, that they are not spamming, and for example, that the operator is actively fighting against spam and attacks which should come from their network to others. They have to operate 24/7 technical NOC without IVR, because the problem during the attacks was that if you call somebody, it was a problem that sometimes answer the machine, not real person who was able to actively help to other party which was under attack. And CSRAT team, every member has to be listed in trusted intruder list. And the other point is that every member have to be actively participating every meeting which NIX CZ organize, because we believe that when people know each other personally, then they are able to fight against the problems, and if you know somebody personally, it is much more easier to communicate with them. And new members who are joining this project need to receive a recommendation from 2 current members, and there have to be no veto from current members to join a new member to this project. And that's where the organization rules, and the second thing are the technical rules. Here is a really long list, and I don't want to describe every of these technical rules, because I believe that you are technicians and you definitely know what does it mean. So The current status after 5 or 4 years of existing of this project is that in our exchange point we have certified 19 members and 5 more candidates which are now in process of joining this project. And we cooperate with our national CSRAT.cz team, and we together organize a regular meeting of this team and of Phoenix project together. You can see now the full list. I really believe that for international or global companies, you will see that these are mostly the local one. But for example, as I said, for us it's very important that our members at our platform are actively improving their networks and improve the communication between each others. So it was a quick overview. So I would like to thank you for your attention, and I am ready to answer any questions if you have. So if there are no questions, I will be at Peering Social, and if you want to ask me something, find me, and thank you.
Thank you. Up next is Bijal from INEX. She's going to have a chat about IXP databases. So welcome, Bijal.
Is it working? Okay, hello. I'm Bijal Sangani from INEX. I'm usually here giving an update on INEX and what we've been up to. But today I'm going to talk about the new project initiative of the Internet Exchange Federation, the IXP database. So first, a quick overview of INEX. So just like how Katsiasu-san was talking about APIX, we are the European membership-based organization for Internet exchange points. We have 2 forums a year. We maintain and develop a website and database and tools around that, which I'm going to be talking about later. We have benchmarking, mailing lists, various different working groups, and also we're on social media. So follow us or like us on there. You've probably heard of the Internet Exchange Federation, but just so that you've got a visual idea of what regions we cover, here's a map of what's going on. So we've got FIX. So the Internet Exchange Point database. So this is no new news, I guess. Internet exchange points are considered in many places around the world core internet infrastructure and carry a growing percentage of internet traffic. And while there are a number of different places where you can get this information, there's none that is globally authoritative or complete. So there are options to get data from, you can go to the IXP website itself. There's other directories and other resources. Some of these are maintained by admins, and IXPs actually have no input into it. Some of these are administered by a various combination of manual input and a little bit of automation. But there's nothing out there that is completely authoritative and complete. So the IXP database, what will it do? The first main difference to the IXP database compared to other resources out there is that it will acquire data directly from IXPs through automation. So what this means is that there's no manual input. We will then eventually, once we get the database in a good place, we'll be working with other other sources to aggregate data and to get a full, complete picture of the internet ecosystem. And another thing that we're going to be doing, which I guess is something that's not really available now, is provide valuable insight, reporting, and data visualization. So, things like maps, you'll be able to see where ASNs are, how the traffic is growing around, not just in cities, in countries, but regions as well. So, the data that we'll be collecting from IXPs via the export will be information about the IXPs, the participants, the platforms they're using, so what switches, what vendors they're using, what root servers they're using, as well as software as well, points of presence, and also traffic data. Data that will come via the IXPs on networks will include things like ASNs, join dates, switch. I'm not going to read the list, so you can see that there. But it's not just the data that's going to have data on IXPs, but it's also going to have data from IXPs about their networks that connect to them. So as an example of what is going to be available, you can, and I talked about data that is available. So for example, looking at IXPs in a particular region, you'll be able to see which ones are growing the fastest. We're going to have, and what the growth trends are. So once you start collecting the historical data, we're going to actually be able to see where the traffic is growing, what difference did a new participant joining in an IXP make. What difference did it make to the traffic in the region? What new and unique ASNs are then present at the exchange, which is then available in the city, the country, and etc. How does aggregate growth traffic correlate with growth trends? So you'll be able to see the growth in new members, new participants that join, and also you'll be able to do trending with the data that's going to be available with the new participants. The other real important thing, and I think the interesting thing that you'll be able to see and that networks will be able to use, is what types of networks are actually connected to these IXs. So for example, if you are an access provider and you're looking to connect to an internet exchange point that has a lot of gaming content or has a majority of ISPs or transits, you can then figure that out and see that that's where you want to be and join that exchange. So we'll be able to categorize and facilitate the exact mix of networks that are available at the internet exchange point. You'll be able to see which IXPs have a high density of ASNs and prefixes that you need to reach. So you'll be able to see, as a network, where do you want to join? What is key for your strategy as a network? Where is it going to be the most beneficial for you to join? There's also actually a really cool compare function that's going to be coming along with this. So you'll be able to actually also compare data from IXP to IXP to see what the differences are and what benefits you'll be able to get from the data. There's going to be also further refined queries. So there's going to be the visualization from the IXPD website you'll be able to see. But for people that want to do a bit more, you'll be able to use the APIs, and people that know how to do all the programming can use the APIs to build in your own queries and your own searches and see what else. Whatever your network needs, you'll be able to get that. What routes are going to improve your network, and I guess one of the key things is which ones are unique to the IXP. Some of the questions that we get asked regularly is, which regions are performing best across certain metrics. So you'll be able to, define certain metrics and use that data as well to see where you want to go, what the prefix availability will be, where all the unique ASNs are. what new networks or network prefixes are starting to appear at a region. So for example, if there's a new network, you'll be able to see straight away that a new network has joined an IX, and you'll be able to understand how that's affected the different traffic. We're also, I talked about the visualization tool, so there'll be a map-based visualization tool which you'll be able to see, like hotspots of where things are happening, new prefixes, new ASNs, where they're joining, and all be able to see on a map. And going with the whole theme of automation, a wise man once said, automation is the key to our success. So, like I said, the database is going to be fully automated. So there is a certain level of trust that this data is going to be, is trusted because the data is coming, first of all, directly from the IXPs, and then secondly, that it's going to be automated. So where are we right now? We started working on this project in July 2017, and we've recently launched a limited version of the database. Currently, the database consists of IXPs that have a JSON IXF member export, and you can see a list of the IXPs that are doing this on the URL there. And also IXPs that use IXP Manager. So currently, there are around 22 IXPs that build their own JSON API, which exports to the IXP database, and 53 Internet Exchange points that use IXP Manager. So when we release the second version of the database, which will be in about 2 months' time, all of those IXPs will be in the database fully automated. The current database that we've released, and like I said, it's a very, very limited version of it, is available on the URIX website. And that's the URL there. So there's still quite a lot of work to do. Like I said, we just started working on this project in July last year. It's taken a lot of time to build the database and work out like the database schema, what we want to, how it's going to work, how the integration is going to work with the websites, with the IXPAs, because of course we want the APIX and LACIX and FIX, all of us working together to build this. So now, a role that all of the IXPAs are doing is we're trying to work with the IXPs in our own regions to help implement the latest IXF JSON schema. So we're on version 7 right now. So there's quite a few versions, and there's a lot of IXPs that are using an older version. So what we're doing is trying to encourage encourage IXPs to actually upgrade to the latest version of the JSON schema. And then also we're working with IXPs that are using IXP Manager to update to the latest version as well. So there's a lot of IXPs that, out of that 53 IXPs, I'm not sure what versions they're all on, but there's, we need to try and encourage them to upgrade and help and support them upgrade to the latest version of IXP Manager. And then the next step is, I briefly mentioned this, is that we are going to build the IXPD onto its own website. So that will come in a couple of months. So then it will be moved from the URIX website. We want to work with the community to identify popular queries and integrate into the GUI and API. So there's a lot of, I've been speaking to quite a few people, and there's a lot of large networks here that have the resources in-house to do this. They have the tools and they have the expertise in-house to build tools that can actually help with their peering strategy, help with their peering decisions. What we want to do as well is work with the community and see what do you want? What kind of visualization tools can we bring to you? And then, of course, then there's a lot of development, query training, there's training for IXPs as well. So we're looking to build some manuals and put together videos on how you can automate the data, how they can build their own JSON APIs, and also, how they can use IXP Manager. So, we've already had a couple of IXP Manager tutorials, so we'll make them available on YouTube so that they're accessible for everyone for all IXPs. So not just to help build the IXP, but to continue and to support, continuously provide support for users that are using IXP Manager. And lastly, we are looking for funding for this project. So if you're interested, you can speak to me. We've got quite a few IXF members here. Can I ask you to stand up? Where's the IXFs? There you go. So look around. There's IXF members here. You can speak to about the IXP database, and also Jesse Sowell, who's been really helpful in working with us on this project. So, and he's here. And that's it. Are there any questions?
Hi, Mariana from LinkedIn. So actually, I support your effort, and I know that there's a lot of people in the audience that might ask, why do we need another database, especially if PeeringDB already exists, right? We have our own internal tool that we plan to open source. It's some kind of peering management tool that also manages the configuration part, and it already works with PeeringDB. What we did notice is that the information inside of the PeeringDB is quite incorrect because it's inputted manually. And I see IXPDB as a solution to make the information more correct. And I know that you wear both hats as PeeringDB as well.
Yeah.
And quick question, do you plan to incorporate those two platforms together, or what's the solution? For example, for me, it doesn't matter. I just need an API for both of them, and my tool decides what's the source of truth. Thanks.
Thanks, Mar. Yes, so there is, in the future, I think the IXF would love to work with PeeringDB and to integrate some of the data, and that's something that we need to talk about. So yes, that is the plan, and and I know that PeeringDB also want to work with the IXF. So I think there's a mutual. I can't think of the word now, but a mutual gain for the community, which I think both PeeringDB and the IXF want to see.
Thank you.
So,
I think this is a great effort. Thank you.
Yeah.
Thank you, Bilja. You're done.
you.
No Tom question this time. Okay, up next is our last full presentation. It's IXP Automation with SaltStack and NAPALM by Nick Hillard at INEX.
Okay, good evening, everybody. This is my first apricot, so be nice. Don't ask too hard questions. My name is Nick Hilliard, and I'm Chief Technical Officer at INEX. INEX you'll be familiar with because we wrote IXP Manager. Okay, so the background for our automation project was that we wanted to get into the automation game very early. We started off with root servers in 2008 with a fully automated solution, which was based on a really, really early version, ugly and pretty cruddy. But we designed the structure of the database to store a whole pile of information tokens about what would be useful for future automation. We didn't actually do the automation at the time in terms of configuring switch ports. This was for a couple of reasons. We figured that we didn't really have enough members ports to justify the cost of doing this. We were running, as far as I remember, about 40 or 50 ports at the time, so it didn't really make a huge amount of sense. We had a lot of concerns about automation in terms of, how we could control the configuration on the switches. What would happen if somebody came in and, broke into IXP Manager and then, changed a whole bunch of stuff, and then that would be pushed out to a production exchange. We didn't know what to do with that at the time. But we also had incredibly poor toolchain support in open source software products. It was very difficult at the time to interface with routers and with switches. So all of these things put us in a position that we didn't really want to do it at the time. The toolchains, we're all familiar with them: Rancid, SSH, Bash scripts, and even uglier Perl scripts. There were no framework mechanisms at the time. We have a lot of frameworks these days. But it was very difficult to interface with the sort of equipment that we needed to interface with. But, you know, here we are. We're all in a sort of a DevOps or maybe a post-DevOps world these days. We have a lot of approaches that we can use for automation. We have entire frameworks. The network operating systems have APIs. Some of them have multiple APIs. Some of them have huge API flexibility. But actually, our rationale changed significantly because we'd grown a bit bigger. We've now got 95 peering ports, and I can't really remember how many, 95 peering members, and I think around 150 peering ports or something like that, or 190. And actually maintaining that level of peering ports by hand is simply impossible. So what we wanted to do was take the operator out of operations. We had some specific reasons, and I'd like to clarify that a specific reason in this instance means specific circumstances. We had incidents which, due to manual configuration processes, we messed up the configuration and we broke things for people, and not just, you know, sort of small breaks. These were really big breaks that were seen well outside the country. So this was something we wanted to get away from in a pretty big way. So what do you do? Operational goals. Our phase one approach was to be able to configure all Internet Exchange edge ports, so basic parameters: speed, framing, lag ports, and layer 2 filters. The second thing we wanted to be able to do was to configure the IXP core. And at the time, we were looking at moving from a strict layer 2 network to a VXLAN network. So that involved, obviously, interfaces, BGP, VXLAN configuration, all that sort of thing. And we wanted this to be ready for 2017, the first quarter of 2017, to handle a forklift upgrade. But we wanted to do more than that as well. We realized that, you know, the first automation project you do, it's kind of a test to see, you know, how automation is actually going to work for you. And we wanted to take the experience that we learned from phase one and build as much of that as possible into a phase two system, which we could then actually release to other organizations. Which is to say, to put it into IXP Manager. So that would be user interface information, database stuff, export presentation information. And obviously, that represents a level of network abstraction that's quite difficult to do, and it takes a surprising amount of effort and an input to make sure that the work that you do is actually configurable across multiple systems. So we actually did a couple of different things at the time to help us with that. In terms of approaches, there were a couple of potential approaches that we kind of had a look at. OpenFlow was one approach, Yang was another, vendor APIs was the third. I'm not going to go down through the through this graph. You can kind of have a look through it. OpenFlow, we felt at the time, represented a significant departure from the workflow of operations that we were using to configure the Internet Exchange. It was too different. You know, if something broke, it was too low level to go in and try and figure out what on earth was actually going on. Yang effectively ruled itself out because there's actually only about 2 or 3 network operating systems that support Yang to the degree that you could actually deploy it. I think that's actually changing, but we certainly weren't there in the first half of 2017, which kind of left vendor APIs. And the vendor API mechanism that we chose to support was the native vendor APIs on the network operating systems, along with NAPALM. NAPALM is particularly good because it provides a glue layer. It allows you to interface with automation stacks that you might use for other things, for example, SaltStack and Ansible. And it interfaces on the other side with your network operating system in a way that you don't have to think too hard about how it integrates. And all of these tool chains are actually supported by some very large organizations, which means that the long-term support and the long-term viability of all of these approaches are going to be, it looks good for all of them. Okay, data presentation on APIs. Yeah, this is a bit messy. Vendor APIs are quite often just a sort of maybe a CLI version 1.1 in that you connect into the API. You don't have to think about SSH keys or SSH sessions. All of that authentication security is all dealt with. You just connect in via some form of mechanism which is abstracted away so you don't have to think about it. This is great. They use XML or maybe JSON formatting or something like that to issue a set of commands. And you issue commands, you get a set of replies. Quite often, the commands that you issue are just exactly the same commands that you'd issue on the CLI. Some of the CLIs are difficult. And one of the problems that we ran into on some of the platforms that we looked at was idempotency. So this is what idempotent means that if you do the same thing twice, you get the same result. And this manifestly doesn't happen on plenty of operating systems. So, for example, you can take one of the platforms that we're using, you could take the entire configuration, repaste it into either the API or the CLI, and it would return a whole bunch of errors. And of course, that's impossible to work with. Some of the APIs don't handle sessions or commit or rollback. To these people, I would say, guys, you've got to sort this out. This is 2018 already. And API support was very operating system specific. So, for example, one of our platforms, we had one set of switches which was running in version 16.x, whereas the API was only supported in version 21.x. And because they were a slightly older version of switches, they were never going to run 21.x, which means they were never going to be automated. So they're going to end up pretty shortly being doorstops. So NAPALM. This is the current support matrix for NAPALM. 6 months ago, this support matrix was actually quite different. It had a whole bunch of extra operating systems that were supported very well in the core. And this has actually been trimmed down by quite a bit. This is probably a good thing because some of the support on some of the operating systems was pretty terrible. But even still, every box in this graph should be unconditionally yes. And it is shocking that even in 2018, that vendors are selling network operating systems which are sold on the basis of high-quality automation, where they don't actually support some of this basic functionality. And some of this is NAPALM support, some of it is vendor problems. But we should be running with yes everywhere here. We shouldn't even have this graph. We shouldn't even need it. It should have all of these functions. All of these operating systems should have all of these functions straight out of the box. In terms of what we had a couple of old Brocade boxes. They're very much end of life. There were actually two systems, Fast Iron and Net Iron. We figured, you know what, we're just going to retire those out of the network. At INEX, we actually run 3 internet exchanges, 2 in Dublin and 1 in Cork. The one in Dublin, we have LAN 1 and LAN 2. LAN 1 was we planned to run Arista kit on it. LAN 2 was going to run Extreme. And Cork initially has some Brocade Fast Irons, but we're going to retire those out at some stage in the future to run Cumulus boxes. And it turns out that for various reasons, we're actually going to put some Cumulus boxes into our LAN 2 as well, and remove a whole pile of the bridging stuff, which makes multiple vendors difficult. Again, I'm not really going to go into this graph terribly much, except to say that Extreme sort of has NAPALM support. We actually have it running. But to the degree that we've run it, we figure we can't fully automate the system. There are certain things we can do. We can configure basic ports. We can't do terribly much with that, because we know that if we try to do too much, we will end up breaking configuration in a way that is going to cause us more long-term problems than it's going to fix, which is a bit disappointing, but it is the way it is. Linux, which is to say the Cumulus option, is a completely different approach. It doesn't actually use NAPALM at all. So that means we're effectively going to run our native orchestration system. So which brings us to the question of what exact orchestration system you should use. We took a very scientific approach to this, and our approach to figuring it out was to ask a friend who was working in Wikimedia at the time, and she said, you know, we use SaltStack and it's wonderful. So that was our decision made. So now we love SaltStack, and it is wonderful. She was right. There is nothing particularly special about SaltStack in this respect. We could have used Ansible. There was no reason we couldn't have used Ansible, but we had several years of experience with SaltStack, so, you know, why not use what we're already using? And this is the sort of data flow that, that we now have for a traditional network operating system. And a traditional network operating system, by the way, is a network operating system which uses a single configuration file on the router or switch or network operating device. So we start off with the IXP Manager database. We have code which acts as a data export controller. That presents information out to a provisioner interface, which is a REST interface, and that spits out YAML. YAML is okay. It's got its problems. JSON is okay. It's got other problems. Nobody likes XML, so we're not going to use XML. YAML is, also has the advantage that it's imported directly into both SaltStack and Ansible. SaltStack will inject that into the NAPALM engine, which spits it out to the Salt proxy, and that interfaces with the device API, and you end up with a running configuration. It does look a little bit complicated, but each of these individual components can be controlled quite carefully. Cumulus Linux is a little bit different because we cut out the entire NAPALM layer. So we start off with our database, our export control layer, our REST interface, and Salt master, and that goes directly into the SaltStack state engine. Salt uses the concept of state. It will apply a state to a particular device. It is one way of approaching automation. It's not the only way, but it's quite nice. And again, you end up with a running configuration. The reason that the NAPALM model doesn't really work terribly well with this is Cumulus Linux is not a traditional network operating system in the sense that it has multiple configuration files. You want to edit LLDP configuration, you edit LLDP.conf and hit reload. If you want to configure BGP, you use FRR in later versions of Cumulus, and you apply your configuration however you want to apply it. But it's not fire out a single config file to a single device and it'll work. It's not like that. It is Linux. Okay, so IXP Manager exports a whole bunch of information. Okay, we're good again. So IXP Manager exports several bits of data. Right, okay, we're online again, we're good. And roughly speaking, the provisioner exports VLANs, layer 2 information, layer 3 information, and information which we need to configure the core. The layer 2 information is actually a mixture of edge ports, or if we have strict layer 2 interfaces in the network, it's actually core ports as well. The layer 3 information is going to be the network underlay information, purely for VXLAN. This is what our YAML looks like. If anybody okay, we're back sort of again. Sorry, the laptops at the front here are going on, flipping in and out here. Okay, good. We're back again. So this is a layer 2 interface, and it's got all the sort of information that you'd expect from a layer 2 face. This is type edge, if you look up at the top. This is an edge port. This is a customer-facing port. And it's got all of the sort of things that you need. So it'll tell you whether it's a lag port, whether it's using fast LACP or slow LACP, whether it's the lag master, what the speed is, all of this sort of thing. It also has a section at the bottom about the VLANs, which is to say the VLAN tag, and the MAC addresses. We kind of assume that everybody is running internet exchanges using tagged VLANs if they're using strict layer 2. It doesn't always happen, but we do recommend it. This is what a layer 2 core interface looks like. It's a little bit different. We figured we actually had to build in support for legacy protocols such as spanning tree protocol. I don't think we liked to do that, but on the other hand, it is a practical solution for smaller internet exchanges. It has its problems, we all know, but hey, we live in the world that we live in. And this YAML is consumed directly by Salt. It gets injected directly into Salt and is applied to a specific switch configuration. And that switch configuration will then, Salt will then apply that to a Jinja template, and the Jinja template will create a configuration snippet of some form. Okay, and this is what the Jinja looks like. This is kind of what Jinja looks like, for pretty normal stuff. So you can see pretty much what it does. It's quite easy. You define your interface. This just sets up the description. There's a bit more sort of junk at the top and the bottom than we'd like, which makes the Jinja a little bit more complicated than we'd ideally like. But I think it's pretty comprehensible. This is what happens when vendors do the wrong thing. This is how to configure speed on an Arista device, on an Arista interface. It would have been a much easier proposition if the vendor had just said speed followed by an integer, and duplex followed by full or half, and auto negotiation forced or auto. But they didn't do this, and we ended up having to create this Jinja monstrosity in order to support that. But hey, we're all used to the occasional hack, so I don't think we should be surprised by this sort of thing. Modeling. We had a lot of we put a lot of thought into modeling because different switches, even though you have your information presented in, you think you have the same information about your switch. Different switches use different approaches. And a good example of that is link aggregation. So if you take a Brocade, it will have individual interfaces. And then on one of the interfaces, you say, in fact, the first interface of the link aggregate, you say that it's a link aggregate, and then all of a sudden it will block you from making any configuration changes to any of the other ports in the lag. And again, this comes back to data, or at least configuration idempotency. While while that is a mechanism that worked very well historically because it stopped stupid user errors or stupid operator errors, and by the way, we're all stupid operators, we all make mistakes. It also means that if you apply a configuration snippet to a Brocade device and then reapply the same configuration, the second time you apply it, it'll return an error. And your automation system somehow has to deal with this, which is quite a difficult proposition to handle. Brocade is quite different. You configure up the, Extreme is quite different. You configure up your configuration, your physical ports, and then you just say enable sharing. And then when you say enable sharing, it actually wipes the whole pile configuration off the ports, and then you have to reapply it. So you have to build that into your modeling system as well. Other devices, they will use virtual ports such as port channel or bond 0 or bundle interface or whatever it is. But even for those situations, the semantics aren't the same. So for example, say on a Cisco port channel, you put the port channel number on the physical interface. But on Cumulus Linux, you put the physical interfaces into the bond interface configuration. So all of these things cause a huge amount of headwreck. And the important takeaway from this is that your data model has to be flexible enough to be able to handle all of these things. We ran into trouble. Upgrades just cause a huge amount of grief. We weren't running containers for our management systems, which meant that when we did an operating system upgrade of one form or another, it broke because NAPALM is pulled in using pip, and some of the Python packages are pulled in using the native operating system, and that broke a huge amount of stuff. At a certain stage, we had to upgrade from Jinja 2.7 to 2.9, and we ran into certain issues there, and we had issues with SaltStack upgrades going from SaltStack 2016.11 to 2017.7, even though it's only 8 months apart. There were significant problems that we ran into with those. A lot of these issues you can actually solve with containers. We haven't gone down that approach. We're just a little bit more careful about how we handle upgrades on our provisioning servers these days. This is Jinja 2.7. It's really nice and clean, looks very well. This is Jinja 2.9 because it turns out that on Jinja 2.9, if you attempt to iterate over that particular variable structure, it will return an error, and your template will explode, and SaltStack will explode, and everything just falls over in a heap, and it's a pain. This isn't very helpful. The release notes said, I don't know, I mean, does this sort of release note really tell you about the true horror of what you're doing? Is this normal with DevOps? I just don't understand. I mean, you know, they should have said, look, Jinja 2.9 is going to break your templates horribly, and here's how to fix it. But they didn't do that. There we go, DevOps, gotta love them. This is what happens when you do an operating system upgrade, and it upgrades bits of Python, but doesn't upgrade NAPALM. It's pretty ugly. I guess if you don't use your containers, you're going to end up with this. I love this error. This is such an informative error. It does this wonderful stack dump. And right down at the bottom, it prints out, type error, bool object is not iterable. Does anybody understand that? I don't understand that. Martin understands that. Martin is very clever, and he understands that.
Your problem is Python 2.7 versus 3.
No. My problem was this. This was SaltStack master 2017.7 talking to a SaltStack client running 2016.11. And when I upgraded the client, it worked fine. I mean, what gives? I mean, this is like crazy DevOps stuff. We're network heads. We're not supposed to understand this sort of nonsense. Okay, anyway, I just had to do that rant. Session-based configuration merge. This is where automation is really cool, because each time we do a configuration run, we actually wipe the old configuration. So our configuration templates look like this. They start off with no router BGP. And each interface that they try to configure, it says default interface, which is to say wipe all of the old configuration on the interface before you do anything else. This is wonderful. because this means that every time you do a configuration change on your device, you know that you're starting off with a completely clean configuration. This is well supported on a couple of the network operating systems that NAPALM uses. And just this would make automation viable. Deployment workflows are really important as well. NAPALM will support all of these fancy features like configuration testing. You can see what your configuration is going to change on your device. You can then load it up in your device, and then you can commit the configuration change to the device. SaltStack and Ansible and most other automation systems also support different deployment environments. So you can say that you've got a whole bunch of switches in your production environment, or if you're INEX, you can say you've got a bunch of switches in LAN 1, another bunch of switches in LAN 2, and a couple of switches in your lab test environment. It's a really good idea on day one to get these systems in place, because it means that you can roll out changes and be relatively sure that you're not going to apply your LAN 2 configuration to LAN 1 or your lab configuration, God help us, to anything in production, because for sure that would break stuff. This is what happens when you deploy it. It's still, in some respects, it's a little bit complicated. I mean, we have this well documented. These are the sorts of commands that we have to issue. The important thing over here is test equals true on the command. And this command loads a template up to the switch. In fact, it pulls the entire interface configuration for the entire switch, uploads that entire configuration, does a session-based configuration merge, and determines that the only changes are down here, where it's going to add in a new MAC address into a MAC ACL. Right at the bottom, it says result true. There's no errors, which is pretty good. This is where we actually apply the configuration change. So we use test equals false and commit equals false. So when we issue this command, it actually uploads the configuration and puts it live. And the third thing we do is to change that to commit equals true. And that actually commits the configuration to the running configuration. And as you can see, it's pretty easy. The commands are a bit of a handful, but you use cut and paste. And so long as you have test equals true enabled everywhere for your first one, you're pretty okay. This is the same sort of thing on Quagga. Again, we have test equals true. We're using a different Salt environment over here. That's the lab environment. What we've done here is just removed a whole pile of configuration stuff relating to FRR, which is the current, or at least a fork of Quagga. It determines at the end of all that the service is going to be reloaded. Now, because it hasn't actually made any change, it's not going to reload it. If you want to reload it, you actually have to set test equals false. And when you do that, it'll work fine. So where did this get us? In the phase 1 result, which was to say early 2017, we were able to meet all of our project goals, and we built this. We used the system to do a forklift upgrade of our entire Exchange LAN. We were able to do the entire upgrade in 2 6-hour maintenance windows on 2 consecutive weeks, which, if we had tried to do this manually, we would have broken everything, and it simply wouldn't have worked. The operations workflow has been vastly improved. It's much simpler, it's much safer, and there's an awful lot less scope for operator error to cause problems. But more importantly, there's now a single authoritative set of data about how the network is configured. We can model that in labs, and we can do all sorts of things with it. But it means that we're now past the time when you put a configuration on a network device and it's there, and that's the authoritative source. The authoritative source is now the database. In terms of phase 2 progress, our abstraction model is now complete. IXP Manager coding is actually complete, but it does still need refactoring. We still have a tiny amount of work to do with Cumulus relating to forwarding FTP entries on switch ports. We have this actually released in the current version of IXP Manager. There's a special config token that you can put into the configuration file, which will enable it. And it was planned to be released in 2017 Q4, but unfortunately just got delayed just due to workload. We have to write a bit of documentation to make it clear, because this sort of stuff is still not necessarily terribly easy to do, and it's more applicable to slightly larger internet exchanges. But for the internet exchanges that need to do this, I think this is well worth it. So this is what it was like then. You log into your switches, you type in the incorrect configuration, and then years later you find that there was a spanning tree like link set with the wrong cost, which is why your traffic was going assways for years and you could never figure out why it was happening. I'm going to admit that we did this, and we did find out configuration boo-boos years later. But this is what it's like now. We configure it using a graphical user interface. We refresh our data on the SaltStack, and then we deploy, and it comes up and it works, and it's great. So thank you very much. I'd like to particularly thank our sponsors, ISOC, Netflix, Swissix, Grix, Nix, and also Interland. I see Erica in the audience here. All of these people, all of these organizations have made the current development of IXP Manager possible, which has made this presentation possible. So thank you very much.
Thank you. We're a bit short on time, so if anyone does have a question, grab him on social.
Yeah, cool. Thank you.
Oh, you got? Make it real quick.
Hello, Nick. It's my name is Christian. I'm from Interland. Just a very quick question. Do you think about creating like an interface to interface the XP Manager with any kind of accounting, billing software?
Okay.
This would be a nice addition to whatever exists.
Right, okay. So this is slightly different to what we're talking about here. The short answer is no, but we will put in some tokens to allow and reporting to allow some level of configuration. But IXP Manager will never be a billing platform. But yeah, it's the...
Okay, thank you.
Great, thanks.
Thanks, Nick. Okay, next up we have 1 million IXP personals. So everyone needs to be quick. If you submitted an IXP personal, can you please pop up now? If you don't remember if you did, this is who did. AMSIX, BBIX, BKNIX, China IX, Equinix, Extreme IX, HKIX, JPIX, JPNAP, Mega IX, Myanmar IX, Mumbai IX, MyIX, NZ IX, PH Open IX, SGIX, and TPIX. That's the APAC IXs, then we'll do the non-out-of-region IXs after that.
Hello everyone, my name is Alexander Mitrov from AMSIX. Most of you know us for operating the exchange in Amsterdam, but we also have an exchange in Hong Kong and India. The exchange in Hong Kong is located in the Cyber location, but also is accessible from Mega HK Colo and both Equinix location HK1 and HK2. At the moment, we have around 43 connected networks, and we do about 39 G of traffic, and we use a set of BERT route servers. The most recent update for AM6 Hong Kong is that now we also offer mobile peering, which is mostly used by mobile operators. And from recently, we can also say that everybody who's connecting from the other locations, then sign of favor can be connected just with the internal cross-connect, and there are no other extra charges involved. The IX in India is located in Mumbai and is hosted by SIFI. And the exchange is located in SIFI Rabale, Tata LFSB. And as of today, we can also announce that the exchange will be expanded to the GPX location. The exchange is fairly new. So at the moment, we have 4 connected parties, but we expect many more parties to connect, and as long as they arrange the co-location and the licenses. At the moment, the traffic peak is 5.9 gigabit. In India, we also use a BERT route service. If you have any question, feel free to talk to me during this Apricot event, or you can always send us an email. Thank you.
Hi, I'm Satoru from BBX. BBX operating 3 IX, Japan and Hong Kong and Singapore. Tokyo has 7 POPs, and Osaka and Hong Kong and Singapore has 1 POPs, Mega I and SG1. Totally, we have 119 plus ASN and 1 Tera plus traffics. And we operate root servers by using BARD and Cisco. We attend peering social, so please contact these 5 persons. Thank you.
Hi everyone, I'm Nan from BKNX. So BKNX stands for Bangkok Neutral Internet Exchange Point. So we're based in Bangkok, Thailand. Now we operate 2 locations. We have 19 connected ASN, but although we have 19 ASN, but we have almost 200 ASN behind them. So we have a peak traffic around 23.9 gig. So we run route server. So the recently update, we gonna deploy the first 100 gigabyte in last year. And also this year, we're gonna have a third pairing forum, which will be held in 22nd and 23rd May. So we welcome you to our event, and see you all in Thailand. If you have any question, you can contact me as well, or find us on the Pairing DB or HPDB as well. Thank you.
Hi, I'm Yali Liu representing Chainix. Chainix is the first internet exchange in mainland China, and we have the IX located in Beijing, Shanghai, and Guangzhou. We currently have 20 plus active AS connected, but we have more members than the connected ASNs because some of the members don't have their own AS and they use ours or through other means. And our IX are interconnected, and this is for connectivity in domestic China only. So if you are overseas, you're global, but you have presence in China, we would welcome you to connect to our IX. Thank you.
Hi, this is Vijay from Equinix IX, and we actually operate the IX platform in 6 metros in APAC across 4 countries. Currently, we have 603 unique AS numbers in our platform. We actually have 2 route servers to give multilateral peering, and we do support the private VLAN for the bilateral peering also. And we have recently refreshed our IX platform, and which can provide 100 gig ports at a very short period of time. So if you guys are actually running multiple 10 gigs and if you would like to move to 100 gig, please approach me, and Raf is here. I'll be around here for next 2 days, and you can catch me around. Thank you.
Hi, I'm Ronak from Extreme IX. 6 months ago in Sanog, I was giving the IXP person's presentation, and the numbers were half of what they are here. So in 6 months, we have grown nearly double. And thanks for all of you to support us, the content providers, the ISPs. As you can see, we are doing 170 gigs of traffic right now, 150 ASNs connected, and 100 plus in line. Anyone who wants to contact me, I'm here till 28th, or you can email at ix@xdme.net.
Hello, everybody. I'm Kenneth Chen from Hong Kong IX, and we are operate under the Chinese University of Hong Kong, and we have 2 core sites in the university, HKS1 and HKS1B, and we have 4 satellite sites in the Hong Kong data center. They are CITIC, iVantage, NTT, and KDDI. We have more than 270 AS number connected, and we have over 1 T traffic just on yesterday. We over the 1 T traffic. And this is our information appearing DB, and as mentioned earlier, and this year we will co-host with HKNOX for the Peering Asia 2.0. So please come to Hong Kong to join us and support us. Thank you.
Hello everyone, my name is Masataka.
And I'm Joanne from JPIX.
Let me introduce shortly about JPIX. JPIX have 2 networks for exchange. One is JPIX Tokyo and another is JPIX Osaka. JPIX Tokyo has 5 POP and JPIX Osaka has 3 POPs. We have 174 members for JPIX Tokyo and 47 members for JPIX Osaka. Recently updates is our new POP is called Shio-sama Data Center, and we are extending subnet for JPIX Tokyo from 24 to /23. Thank you very much.
Hello everyone, my name is Ken from JPNAP. So we are operating 2 independent IX in Japan, in Tokyo and Osaka. In Tokyo, we have connected over 130 customers, and we have 7 connection points. In Osaka, we have about 40 customers and 3 connection points. And we just launched a new launch a service in called Tokyo Data Center. And our exchange traffic is almost 1.3 terabit, and it is one of the largest IX in Asia. So if you have any question or interest, please feel free to ask me and our teams. Thank you.
Megaport. We run several IXs in the region. I'm not going to read through all the numbers for time. These are Australia and New Zealand, Australia, and New Zealand, Hong Kong, Singapore. Main update for the last year is Hong Kong has been rolled into ANSIX Hong Kong, so sort of ceases to exist as a Mega IX now. Thanks. I might out of region IXs to join the line now as well. Asteroid, Brazil IX, D6, Interlan, South African collective IXs, Lynx, LONAP, NIC, CZ, and NIC Slovakia. If you could all join the end of the queue so we can get straight through this. Cheers.
Hello, everybody. My name is Damien Kai. We set up this exchange recently on last September 2017. Now we have 11 members, 9 operators already connected. Total AS number will be 12. So our traffic is not significant, but we will grow very fast, I think. So if you need more information, please contact me. Thank you so much.
Hello everyone, hi, I'm Vivin from Mumbai Internet Exchange. We have moved from a single location Internet Exchange point to a distributed Internet Exchange in the last 1 year. We have almost 100 networks right now with a peak traffic of 120 gigs. We moved from the Cisco based network to Juniper to accommodate the 100 gig ports. And then in 2017, we also entered into a joint venture with DKIX for the technical and all the other support. Next slide. Got one more slide. Yeah, so these are the 3 data centers which we are currently operating. So we are in carrier neutral, data center neutral peering platform. We started at WebWorks and now we moved to NetMagic and the Tata LVSP facility. Yeah, thank you.
Internet Exchange. We have 2 nodes in Klang Valley, one in Kuala Lumpur and the other one in Sabaja. We are going to launch our 3rd node in IPDC, Iskandar Putri Data Center in Johor. There will be a satellite node. Number of connected ASN is about 75. Our traffic profile is balanced. And we do have route server. And if you are interested to peer with my ex, you can contact the email as well as you can contact me. Thank you very much.
Hi, I'm Chris. I represent NZIX. NZIX was created out of the Internet Association of Australia. Since then, we've become our own entity, and we run independent. So we're a non-for-profit, carrier neutral, data center neutral. We have 73 members now. Traffic volume 45 gig plus peak. We have 3 locations in Auckland. The data center, Merrill Drive focus, and we're in Peering DB. And we're probably over the next while looking to extend into other locations as well.
That's it. Thank you.
Hi, I'm Achi, and I'm representing PH Open IX. This is a government-run internet exchange in the Philippines. I don't work for the government. This is more of an advocacy thing to help improve the connectivity in the country. So we only initially had 1 location, which is in Manila, but we extended to Cebu, and now we're working on Davao. We operate based on donations, so we don't actually have funds for that. So we're trying to get sponsors also for governments and carers in the Philippines. Thank you.
Hello everyone, I'm C from Singapore Internet Exchange. Currently we only operate in Singapore. So our point present, we have 6 locations, and we have one satellite location. We have 2 more satellite locations coming out on Q2 2018. Total number of members right now is 90, and our peak traffic is around 150. We do have route server using Cisco SR 1000, and our coverage currently expand to 7 data center, up from 3 in 2017, and the 2 new more satellite data center will be coming up on Q2 2018. And currently, we are also exploring extending our 100 gig to our satellite nodes. Thank you very much.
Hello, good afternoon, everyone. This is William from TPX again. TPX is in Taiwan, and we are the biggest internet exchange in Taiwan. There are 4, but actually active is TPX and Twix. They have a representative here also. And TPX is operated in LY and HD building, and we have 42 ASNs, and peak traffic is now 96 gig, and which is we have 80% growth within a year. And of course, we have a route server, and we have several featured members you can see there, including some global carriers. And you can find us on the PeerDB. And we have 2 representatives, William, myself, and Julius here. Thank you very much.
Hello everyone, my name is Nurani and I work for Asteroid International. The slide is a little bit, template is a bit funny for us in that we do things a little bit differently. We've developed a highly efficient and highly automated IXP platform. We built the first one in Amsterdam at the end of last year, and we are building it basically wherever there's a need. So we believe in partnerships. So for example, we've partnered with McAllen Data Center in the south of Texas in the US. So if you want us to build an IXP for you, we will do that. We've also launched campaigns for new IXPs and have gotten a lot of support for an IXP in Mombasa, which we will be building in the coming year. And through our platform, through the API and our portal, you can monitor and manage all your aspects of your peering ports. If you're interested in talking to us, find me or email me throughout the week. Thank you.
Hello everyone, my name is Milton. I work at NIC.br, a private non-profit organization. We run Internet Exchange Point in Brazil, in 30 cities. Those interested in connecting to Latin America region, consider to connect to INEX.br in São Paulo City, because São Paulo City has more than 1,500 participants interconnected there. So, thank you very much.
Hi everyone, my name is Wouter. I work for DKIX. Just a brief update. In Europe, we've added Berlin to our exchange points. We have our cooperation with Mumbai IX. New York has become the largest IX now, or DKIX New York in New York. If you want to approach us, if you have any questions, please feel free to contact me or any one of my colleagues here. Thank you.
Hello everybody, I'm Eric from Interland Internet Exchange. We are an internet exchange based in Bucharest, in Romania, southeastern Europe. We have a network distributed over the country, having 6 POPs in Bucharest and in other cities in Romania, major cities, and an international POP in Frankfurt. We have 83 ASN connected, and we reached recently 140 G of traffic, big traffic. We use Bird route servers, and our recent updates, we plan to open a POP in Moldova region. We recently implemented the IXP Manager at the end of 2017. We have implemented remote peering and virtual patch additional services. And if you have more questions, I'll be around. Thank you.
Hello, everyone. My name's Ed. I represent INCZA Management Committee. We're a not-for-profit that runs 3 internet exchanges down in South Africa. We're 100% community-run, 100% not-for-profit. And over the past 22 years, Jinx, which is the oldest IX on the African continent, has had 100% uptime. Our latest projects have been to get the IXP multi-sites, which is still quite a new feature down in Africa. So we're glad that we've been able to extend all of the IXPs that we run to operate out of various data centers. We'd love to see you come and peer down in South Africa. It's a great environment which has really taken off. Pretty much all of the Western CDNs have or are landing soon. I'm happy to answer any questions you might have, or you can find our INCS manager, Nichelle, somewhere in the back there. And yeah, hope to see you soon.
Hi everyone, I'm Curtis Lindqvist from Links. We operate exchange points in the UK, and we also have one in Northern Virginia in the US. One of the maybe not so exciting but news is the new logo and layout of Links, of course, you can see here. I'm here together with my colleague Mark. If you have any questions about peering in the US or in the UK, you can please come and visit us in person or down by our little stand in the foyer. Thank you.
Hello, peering people. My name is Richard Irving. I'm here with my colleague Will Hargrave. Long out of Mutual Exchange, been peering in London since 1997. We'd love to talk to you if you want to come and peer in London. These are up there. Come and see me.
Hello again from the stage. As I said before during my presentation, I will tell you some numbers about NIX-CZ and NIX-SK. So NIX-CZ is the internet exchange point in the capital of the Czech Republic. We operate our exchange point in 6 data centers. Currently there is connected 150 networks, and the peak traffic is 629 gigabits, which we reached last week. And what was untypical for us that we reach this peak traffic in off-peak time, because there was a TV broadcast of match, ice hockey match from the Olympic Games between Czech Republic and Russia. So that's nice. And please, second slide for NIX-SK. And NIX-SK is for us a quite new project. We operate this exchange point in the capital of Slovakia since 2015, and currently we interconnect 45 networks, and the peak traffic is 53 gigabits. So thank you.
Thank you. So we've run a bit over time. The NOGBOF is in here now. Don't forget the peering social in a bit under an hour. Make sure you've got a ticket from Raf or one of his colleagues. Otherwise, you might be sad. Crystal Hall, it's some way that way. Thanks for coming, everyone.